what are all the solutions to the equation above? And we have x plus 3 times x minus 5 is equal to 5. And you want to be very careful here because you probably have some experience with algebra that, hey, once I factored it out, maybe I could say, okay, maybe this needs to be equal to 5 or this needs to be equal to 5. That is not the way that it works. That would not make actually logical sense. In order to kind of make the factoring useful, you have to be able to say, hey, the product of these two things is equal to 0. Because if the product of two things is equal to 0, then you know that either one or both of them need to be equal to 0. So we've actually have to do a lot of algebraic manipulation here to get it into that form. But let's see if we can do it. So the first thing I would do is just multiply out x plus 3 times x minus 5. So what's that going to be? Well, it's going to be x times x, which is x squared, plus x times negative 5, so I could say that's minus 5x, plus 3 times x, so that's plus 3x, plus 3 times negative 5, so it's minus 15, and that's all going to be equal to 5. And let's see what we can do from here. We could say this is going to be x squared, and then these two terms right over here we can add together. Negative 5x plus 3x is negative 2x, and then we have minus 15 is equal to 5, And let's see, we can now subtract 5 from both sides. So you subtract 5 there, you subtract 5 there, and we're starting to get to the home stretch. And we would get x squared minus 2x minus 20 is equal to 0. So now we're in business. Now we have this quadratic in a form where we just need to figure out what x values are going to make this expression equal to 0. And the first temptation is to see, well, is there any way that we can naturally factor this? So is there are there any two factors of 20 that and it's going to be, one is going to be positive, one's going to be negative since their product gets us negative, or if I add them together I get to negative 2. So let's see. No, nothing jumps out. You have 4 and 5, 2 and 10. Yeah, nothing's jumping out at me. So we can just resort to the quadratic formula here. When the quadratic formula tells us that if I have ax squared plus bx plus c is equal to 0, then the solutions of this quadratic equation are going to be x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And I don't tell people to memorize a lot in life, but the quadratic formula is one of those things that it's not a bad idea to memorize. But you should also watch the Khan Academy videos on how this is proved, and this comes just naturally out of completing the square on this thing right over here. So also understand what it's actually saying, but it's also a good thing to know, because just like that we can apply it to this. So in this context, our a is 1. It's the coefficient out here that's implicitly out there. So a is 1, b is negative 2, b is equal to negative 2, that's this coefficient right over there, and c is negative 20. C is equal to negative 20. So the roots are going to be x is equal to negative b. Was going to be negative of negative 2. So negative of negative 2 is going to be positive 2 plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times negative 20. So instead I'll put a 20 here. And since it's a negative 20, but I'm subtracting it, I could put a plus there. And then all of that over 2a. Well, a is just 1. All of that over 2. So it's going to be 2 plus or minus the square root of 4 plus 4 times 20 is 80. Of 84 over 2. Now already, if I'm under time pressure, I already see some choices that are starting to look a little bit like this. But let's see if we can get to the right solution here. So can I simplify this more? Well, let's see, the square root of 84. 84, that's going to be divisible by 4. 84 is the same thing as 4 times 21, and all of that over 2. And this is going to be the same thing as, I'll scroll down a little bit, get a little bit more space. This is going to, x is going to be equal to 2 plus or minus So this would be the same thing as the square root of 4 times the square root of 21, which of course is 2 times the square root of 21, all of that over 2. So if you divide each of these by 2, which we are doing right here, it's going to be 1 plus or minus the square root of 21, which is this choice right over there. So it looked like a fairly benign thing, but we had to multiply it out, set it up in kind of a form where the quadratic formula would apply, and we got a fairly hairy answer.